Today we are working on a commercial embroidery motherboard. Customer brought this in. He brought this in. And he also brought these parts here. I never worked on an embroidery commercial machine before. I asked the customer what's wrong with the device, and he said that this board burned out. And that board should be on the side here. So what they did, his IT guy, he cut off that board to remove it from this unit here. And the customer bought another one, which is this one here, and he wants it to be soldered on to the main board here. I do not know if a prior repair attempt was done on this, but the pins do not look good. They look all bent up, but the board is functional, as the customer said. And he said to make sure that the heatsink goes on the inside, which makes sense, of course, because metal on metal, and there's some type of thermal pad in between, which is this one here. So this has to go on here, and then we're gonna solder the board. We can put this in later, it doesn't have to be done now, but what we have to do now is we have to clean all the holes on the bottom here, and then we're gonna solder this piece on the main board. And the second thing the customer wants us to do is to change the battery on this board here. And it's a 2-pin through hole battery. He already got us one. So that's what we will be doing, and he needs this device as soon as possible. So we're gonna go ahead and start with the battery. I honestly do not know the make and model of this embroidery machine. I'll see if I can find out, and I'll put it in the description. Let's start with this board here, and we're gonna desolder 2 pins from the bottom to remove that battery. Okay, so we're gonna be using low melt solder, and let me clean the tip. That's one, and that's the other one here. Okay, and now what we can do is we can easily wick off solder, and we should be able to remove this battery. See? Look at that. Okay, so this is good, and let's do the other one here. And just look at that solder wick. Now we can easily remove this battery. But in case there's no markings on the board, I want to see where plus and minus is before we remove this battery. Yeah, it's marked. So right now all we do is, it looks like maybe the battery is also taped from the bottom, so it's not only solder, but it's also tape. So we're gonna have to pull a little bit hard on it because there's white tape under it, and right there, it's out. Now we're gonna put the other one, and again we have to just make sure that we put the battery in correctly. That's plus right here, and that's our battery. And that's plus right here. Battery is in, and all we have to do is solder the back 2 legs, and the job is done. So we're gonna flip the board, go under the microscope, and finish this job. And let's use our fine steel brush to just clean this board. And look at that. Apply flux here, and then we're gonna apply flux here. Okay. Of course, it has to be better than factory. Somebody in the comments said the reason we apply a lot of flux is so we can get it done better than factory. 2 thumbs up, 100% true. This is the new battery here, and this is the soldering on the 2 pins on the back. Just want to check on the polarity, make sure everything is correct, and plus, very good. And it's very important that the polarity of the battery is correct. We do not know if the circuit board has any type of protection to not cause any damage if the battery is in fact switched negative, positive, positive, negative, but any good tech should not make that mistake. Now we're gonna be working on this board here. The first thing I wanna do is make sure all the holes are desoldered properly. Then we're gonna insert the card and solder all the pins. It's gonna be a little bit difficult working on this under the microscope because of the height of this device, the heatsink. I would say maybe about 4 or 5 inches high. So we're gonna have to raise the microscope up high like this. And I cannot rest my wrist on the bench anymore. I have to work like this. But that's okay. And I see signs of flux, a lot of flux. That's probably factory flux. No job is too hard with this wick. I'm sure we're gonna consume a lot of wick here because it's a big board. I'm gonna add just a little bit more flux to help with the wicking process. It looks like we may still have part of the pin inside here. We'll look at this from the other end. And we have a long way to go.
Turns on, but the video is blank.
2012. Okay, is it here or he want to send it? It could be one of the two things, either a motherboard issue or a screen issue. If it's a motherboard, no, he need to send the whole MacBook so we can test, not only the motherboard. And if we are able to fix it, it's gonna cost him $295 or $65 for the repair attempt. Okay, let's flip this. And this ring is totally gone, but it doesn't look like it connects to anything, and this one does not look like it connects to anything either. You see this ring, how there's a line, a trace going down. We do not have any traces on these two pins. If you notice, I'm just tapping and I'm not going back and forth, so we do not damage any rings. And what is this? What is this? Wow. Okay, we have a problem here. we have a problem here. This is not workable. I'm not able to do anything with this block tilted like this. I'm gonna have to remove the heatsink, and we're gonna have to remove the screws from here so I can work on this board and see what's going on. It looks like we have a ripped trace that we need to fix. Otherwise, customer is gonna have issues with this device. Let me quickly remove the heatsink and we'll take it from there. And finally, we have to desolder two wires. And I have to mark, there's a black wire and white wire. I have to mark where the black wire is so we can solder it back. And what I'm going to do, instead of desoldering the wires from the board here, I'm going to desolder them from those 2 points here. I already marked black as being on this side here. And now we should be able to remove this heatsink just like that. Now I can comfortably work on this board. So the pads are good here, good, 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 until we get up to this point where we have a ripped trace. Okay, this is going to this. And this one goes to this. And this one goes to this. We're gonna have to clean up and look at this closely because right now everything is a mess. Let me finish with cleaning off those holes and then we'll worry about the traces. And this job is gonna cost the customer more money because we're gonna have to do more work. The customer is not concerned about the money, but he just wants this to work. This is part of the ring. Look at what we have here. Okay, time to clean up. And it's gonna take a lot of swabs to clean this mess. We're gonna have to charge the customer for 1 kilo of swabs, 2 rolls of wick, and 1 syringe of flux. Because that's what it will take to get this job done. It's a big board. We are used to working on microscopic devices and components. 1 hole on this board probably makes up about 100 size 201 SMD components. Just making sure the holes are clean. Okay, so everything is good. The holes are clean. because the holes are deep and flux can get stuck inside. So we have to make sure that we do not have any solder inside the hole. Okay, looks like it's starting to go in, but not fully in yet. It was hard work trying to fit those pins inside the holes. So we finally did. And let's start by soldering a few of those pins. Add some flux. And we'll just flip the board and do everything from the back. We want to make sure that all the pins are inside the holes and we do not have anyone that's missing, because once we start soldering, it's going to be hard to fit any pin inside the hole. Looks good. Very nice. It took some back and forth to get those pins inside the holes, but the good thing is they are in and we are ready to solder. And look at just how long this board is. Fume extractor, very important because we're going to be consuming a lot of solder. Maybe we can see better like that without the glare. So far so good. We still have a few more to go. And we do not know if this one has a ring on it or not. And it doesn't. This one does not have a ring on it, so we're gonna have to make sure it's soldered from the backside. I mean, a small ear swab is not gonna work for this job. We need like a humongous ear swab to clean this, but I'm gonna go over it a few times. We need the giant's ear swab. You know, like the giant we read about in stories. The giant and the small guy. Now we're gonna use our steel brush. This is our fine steel brush right here. And this will get rid of any gooey stuff stuck on the board. Okay, this brush is amazing. And look at that. Better than factory. Better than factory. Now we're going to use the other end of the brush because this brush comes with two ends. And if you are interested in this brush, you can find it on our website. It's pretty cheap. And we have this dry wipe to absorb all that residue of flux. Because right now, even though we cleaned with alcohol, there's still a residue of flux on that board, so the dry wipe is gonna get rid of them. And you can tell how this wipe is brown now. Look at this. Okay, so let's see. Look at those joints. Look at those nice joints. We do not know if this one is making a good connection or not because, yeah, it's not. Because there is no ring on the bottom, so solder is just sticking onto the pin. Meaningless. We're gonna have to solder this from the back if a ring exists. Beautiful job. Okay, so we're gonna flip the board and start with this pin here. We're gonna have to find a way to solder that pin to its respective trace. Since there is no ring here, solder is not gonna stick. So we have to find out where this pin is going to. Okay, so it looks like it's connecting with this broken trace here, right there. So as long as we can get solder from here to here, we're all good. Shouldn't be a problem. Okay, and are we good? And yes, we are very good. Very nice. And right now we do not need to worry about any one of those pins because they're all soldered properly. We already inspected from the back. What we do have to take care of are the ones with the broken traces right there. Oh boy, it's gonna be hard to work on this. Okay, so 1, 2, 3. We have 3 missing traces, we can tell. The first line is going here. The second trace is going here. And the third one is going here. So we're gonna have to start with the first one. We're not gonna be able to use this trace because it's short. Working on this board is very awkward. Maybe I should have taken care of those wires before we soldered this board on. But what can you do? We know this wire is not gonna reach here, so we have to solder another wire. Okay. Let's not get overwhelmed and get the job done. I got a piece of a Cat 5 cable and it has a lot of wires inside, so we're gonna be using those wires. They're already insulated, but we're gonna have to strip the ends. See? We do not have to worry about the insulation because they're already insulated. We're gonna use this wire stripper here. Okay, so we're gonna have to solder this wire from this point of the resistor all the way to this point here. So let's cut that wire. This is the perfect length. Very nice. Now we're gonna have to solder that wire all the way to this resistor here. Great. Solid connection. And wire number 2 is coming from where? How are we gonna do this? We do not know where that wire is coming from. You have to understand, I'm working in a very awkward position. Right now I'm looking from this side and from this side to figure out where that wire should be connecting to. And the microscope, really it's hard to see both ends under the microscope. We're gonna solder this one to this pin. And lastly, we're gonna solder a wire from here to the last broken trace. And we're good. And we have to solder this over this. It's doable. If only I could grab those 2 wires with my tweezers, that would make the job a lot easier, but it's not possible. I do not have room to grab those 2 wires. The only other way to do it would be to remove this resistor and see where that line is leading to and run a wire from there. Okay, so now we have a solid connection. Now we have a solid connection, very nice. Now let's test the continuity between here and here, very nice. And the wire, very nice. So the wire is making a good connection. And we want to make sure that those 2 wires are not touching this and this. And they are not. And the last trace. And this one should be long enough to reach. And now I'm gonna apply overcoat pen over the tip of those wires so they do not short out for whatever reason. Okay, and once this overcoat hardens, then everything is going to be rock solid and no wires are going to shift or move around. Not that this device is going to be played soccer with, but still, we want to make sure that everything is solid. And now all we have to do is put the heatsink back. We're going to solder the wire, the black wire here, like where we have it labeled, and the white wire here. And we should be all good. We have to put this pad between the board and the heatsink. And we have other screws that goes on the side, and we're also gonna hold the heatsink from the bottom by putting 1, 2, 3 screws. Okay, and finally we have those 2 wires to solder. Yeah, it's done. I hope you enjoyed the video. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.